Hi, welcome. In this video series, I'll be exploring how I built Project Vulcan, my high school bipropellant liquid fuel rocket engine. This is not a how-to guide, but something to augment your research. You can use it to help out if it's any use at all, and this is certainly not an Instructable's how-to. So, let's get right into it. In this first video of the series, I'll be exploring my initial design parameters, the starting choices I made when designing the engine. So, the first thing we have to decide is oxidizers and fuel. Firstly, for oxidizers, I'm not going to go with anything hypergolic. Nobody in their right mind is giving a high school student access to hypergolics. I'm not going with cryogenics, way too costly, and they require specialized knowledge and equipment which I do not have. So that leaves, in my eyes, nitrous oxide and oxygen. Nitrous oxide, you need specialized tanks for, piston tanks, things like that. You need specialized regulators for, and it's also quite heavily regulated. I wasn't sure where to get in the UK, other than specialized places, which wouldn't give it to a high school student. That leaves gaseous oxygen. It's used as a welding gas. It's easy to find oxygen tanks. It is easy to get welding oxygen regulators, welding oxygen hoses, and it's quite easy to find parts, oxygen clean parts. So, I went with oxygen. For fuel, this was a handy little table made by Stephen Hyde. I've linked him below, amazing channel. And I decided to go with ethanol/alcohols. This is largely due to the fact that, one, they're quite easy, cheap to buy. I wanted to go with the liquid. Instead of something like propane, where it's just a gas, mixing is in some ways easy, in some ways hard. I wanted to go with the liquid, where I would actually learn fluid dynamics, injector mixing, things like that. We ignore how gas is a liquid, I mean genuine liquids. So, let's look at how I decided my chamber pressure. For the chamber pressure, you need something called a pressure drop. Your upstream pressure, whatever it is, you need a 20% pressure drop across your injector. That means that your chamber pressure should be 20% lower. This is to ensure that there's no backwards flame propagation. There's no flashback. That means fire won't go backwards through your injector, because once it does that, if it gets into the tanks, that is a big problem. So, 20% pressure drop. That means our chamber pressure is dictated by our upstream pressures. For the ethanol, I'm pressurizing it with nitrogen. I'm not really limited with how high of a pressure I can go. You can get a 600 psi regulator for about 50 pounds. That's not going to be the limit. For oxygen, that's what will limit me. I found this nice regulator for about 130 pounds, and it peaks out at about 280 psi, and it's built for oxygen. If I left a 30 psi margin, that gives me a maximum upstream pressure of 250 psi. So, let's let the chamber pressure be a nice round 200 psi. Finally, materials. This is a rocket engine. It's not a rocket. It's not flying anywhere. That means that I can have big, bulky tanks, and my engine can be big and bulky. If there's a hard start, I do have to worry about it exploding to smithereens. It's so thick and heavy and dense that you could put a grenade in there and you'd probably be fine. I went with something very robust. So, for the chamber, I went with alloy steel 4340. It is an aerospace grade steel used in the aerospace industry all the time. It has quite good thermal properties, very high melting point, fairly good heat transfer capabilities and properties. It's very dense and very strong. To me, it was a no-brainer. Then, the injector. The injector has some very small orifices, so I wanted to go with something easy to machine. I went with aluminium. It has pretty good thermal properties, and since there's so much cold fuel behind it, I didn't have to worry about it overheating. Aluminum was a good choice. Finally, the fuel manifold. For that, I went with stainless steel. The fuel manifold is maybe the most technical to manufacture. It has O-ring gaskets, O-ring grooves, things like that. And you want a material that a lot of places are willing and are experienced with manufacturing, because these are some very tight fits. Stainless steel also was a good choice because I don't have to worry about thermals for that section, lots of cold fuels. And stainless steel isn't too expensive. You could also probably go with aluminium. So those were the 3 materials I went with. Now in the next video, I'll talk about all of the design choices I made with the injector. See you there.